Alrighty, let's try solving some exponential and logarithmic equations. There's exponential and there's logarithmic. Alright, we're going to solve them, and it's all based upon this little formula here we'll talk about. Now, before I do that, talk about it too much, I hope you're getting comfortable with logs and the properties of logs. Try not to be scared of them. Lots of people are, especially when I was in high school. First time I saw them, I was like, what is this? It took me a while. I probably wasn't until college because I really understood what the heck I was doing with them. But hopefully you're getting to the point that you kind of make sense of them. They're very useful, but they are a little odd, like with a word. Why do I have words with stuff inside? And these little bases. Anyways, hopefully you're kind of understanding it. Okay, but here's how we solve them for x, like what x value would make these true. Here's the basic building block. If you have an exponent, you can transform it into a log. If you have a log, you can transform it into an exponent. And this right here might make no sense to you. Like, that's whatever. What are you talking about? But here's how it goes. You ready? It's very simple to some extent. If I have an exponent, I can tack the word log in front, and watch. I can just simply switch those two things. Do you see right here how I put the word log in front? The base of the exponent becomes the base of the log. And then do you see how the x and the b switched? Now if I want a log and I want to go back to an exponent, see the arrow goes both ways, I take off the log and I switch the two. You see that? If I'm going this way, do you see how if I took off the log and switched x and b, do you see how I got that? So basically, this little conversion thing where you put a log on and switch the two gets this way. If you take the log off and switch these two, you go back to the exponent. You use this to transform between exponents and logs. It's very important knowing how to transfer back and forth between the two because they're inverses of each other. They're kind of the opposites of each other mathematically. Okay, so let's do this little trick. There are other ways to solve logs than what I'm showing you. If you've seen them after you watch this video and you like your other way, go for it. But this way I found is probably the best for most of my students over the years. Okay, so to solve this, basically we have to always get the exponent piece by itself. So I want to get this by itself, so we do basic solving skills. We add the 6 over. Alright, we now have 2, 5 to the x power equals, that looks like 14. Alrighty, now we got to get the exponent piece by itself, so we can divide off the 2 because it's connected by multiply, so you can divide it off. I now have 5 to the x power equals 7. Okay, with all that, now what I do is I follow my property. I have my exponent isolated, all by itself, so I now have to switch an exponent into a log. So what I'm going to do is I'm going to write the word log. Alright, I'm going to be switching these two. Alright, remember, I put the word log and I switch those two. The base of my exponent becomes the base of the log, so that 5 is the base of the log, kind of a lower. And when I switch these two, well, this base is 5, so won't that 7 be right there? So won't it look like log 7 base 5 equals x? See how I switch those two? If you kind of cover that up for a second, switch the x and 7. See how 5 to the 7th equals x? And we put the word log in front. Now, be careful when you do this. The log 7, the base is 5. That's important. Don't put log 5 power of 7. It's completely different. But that right there is your answer. Now, if you had a calculator and you know more about how to solve these, you can use a calculator to find the decimal value of it. This actually has a value that you could calculate fairly easily with a calculator. But we're going to leave it like that for my answer right now. Again, it is a decimal that you could go farther and find. Okay, now right here we have to get the log by itself. So like before, we have to just do simple algebra. So 2, we have a log base 3, x plus 4 equals 10. All right, get that off, the 2 off, so I divide by 2, gone. I now have log base 3, x plus 4 equals 5. All right, now what do? Well, I'm going this way from a log to an exponent because a log's by itself. So I got to drop the log and switch these two. See, I just dropped it and switch. So if I drop the log, and I'm going to switch these two little guys. So I now have 3 to the 5th power equals x plus 4. All right, and I can actually finish this. So what's 3 to the 5th? You know that, don't you? You haven't memorized. Everybody does. I'm being sarcastic, sorry. 3 to the 5th is 243 equals x plus 4. So what we do to finish this one off, yeah, you minus the 4 over, and you now have x equals 239. That would be your answer. A nicer number here for this one. This one, not as pretty, but you can find the decimal for this. One thing you have to worry about with logs is something called extraneous solutions. And you have to basically check, you have to put this number back into the log original to make sure it doesn't create an error. And what I mean by that is you cannot have negatives or zeros inside of logs. So if I take this and put it right inside there, go 239 plus 4, if that created a negative or a 0, that answer I'd have to throw it out and say it's extraneous. It's not actually reasonable. I can't use it. But we're okay. But you want to start checking your answers with logs when you're solving logs. You don't have to worry about this because powers can be anything, positive, negatives, but logs can have zeros or negative in them. So be careful with that. Again, for both of these, get the exponent by itself, get the log by itself, and then you got to transform it. It's more than meets the eye. Hopefully you caught on to that. Maybe you didn't. It's okay. Transformers, the movie. Anyways. So make sure you transform them and then try to solve farther if you have to, like I did here. Just don't get stuck, don't quit when you get to here. And remember, all you're doing is putting a log on, switching two things, or taking a log off and switching two things. Good luck with logarithms and exponents and solving them. Now, I want to give you a word problem that uses them, or uses exponents and logs and stuff like that. Here we go. Ready for this one? If I invest $100 and expect to get 3% interest each year, then how long will it take for my money to double? That's very practical. This is a formula for exponential growth. A final amount equals principal, which is initial amount, times 1 plus the rate, as a decimal, to the time power. Time is in years usually. So here's information. If I read it, my final amount is 200. My principal or initial is 100. My rate is in decimal, 3%, 3 over 100, or 3 is in the hundredths spot, is what you can think of it as. And we want to find time. So when I plug all this in, I get there in the black. Divide the 100 over, combine this, you get 1 plus 0.03, a little shortcut for adding 1 plus 0.03. Think of it as $1 plus 3 cents. My students like that. Money is always easier for them to think about that way. Anywho, and then here we go, oh, okay, we're going to use logs to solve anything with the power that's an exponent variable power. What you need to do is you need to use logs. To get that variable out of the power, you're going to need logs. And what I like to do is I like to flip it first. I flip these, and then I put the word log in front and switch the t and the 2. Remember that? Put the word log in front, switch t and 2. And if I calculate this with a calculator, I actually end up with 23.5 years. So it takes quite a while to double your money at 3%. If you had a better interest rate, it'd go a lot faster. But that is a very, very practical use of exponents and logs. Good luck with them, and I think you could do really well.